Hello, hello, hello. Today is September 6, 2021. Physics problem number 119. It's the most difficult problem that you've ever seen on my YouTube channel. By far the most difficult. Anyone in high school shouldn't even touch this problem. And I would be very surprised if anyone who passed with flying colors the JEE advanced exam, if they can do this problem. Having said this, I'd be very impressed if of all my viewers, 2 give the right answer. I even doubt whether Alec in India, perhaps even Professor Verma, can do this problem. Yes, I'm serious. Most physics professors cannot do this problem. I have here a circuit made exclusively of superconducting wire. So the entire circuit is a superconductor. Characteristic for a superconductor is that there can no electric field be inside it. I have a magnet and I move this magnet in and out of the coil. According to Faraday's law, there is now a magnetic flux change in the open surface attached to the wires. It's a crazy surface. The best way to see it is that you take this entire circuit and you dip it in soap. And then you look at it, and that's the surface. So, when you move the magnet in and out, clearly the magnetic flux through that surface will change. We give the magnetic flux the letter phi. You can look up what the definition of magnetic flux is, but it is the product of the magnetic field strength times the area, very roughly speaking. More correctly, it is the integral of B, the magnetic field, dot dA, and A is the surface, and dA is perpendicular to the surface. So, Faraday's law then states that if there is a magnetic flux change, then there is an induced EMF in that closed loop. In other words, the closed loop integral of E dot dl is minus d phi dt. That is Faraday's law. So, Faraday says there must be an induced EMF somehow. So my question now is, will there be a current flowing through the wires? Of course, the magnetic flux is changing. If there is a current, the current should also be changing. If your answer is yes, how can that be, as there is no electric field in the wire because it's superconducting? If your answer is no, isn't that then a violation of Faraday's law? Faraday's law says there has to be an induced EMF. A separate question, but in a very intriguing way, they're all connected. Is there a B field inside the wires? If your answer is no, then why is the B field of the magnet not also in the wires? I wasn't kidding when I said this is the most difficult problem I have ever posted. As I said earlier, most physics professors cannot do this problem. And you shouldn't feel bad about it. And the professor should not feel bad about it. It's very subtle. And when you see the solutions, they are truly fantastic. Whether you can do it or not, that makes no difference to me. We'll be friends anyhow. I'll be happy if even one person comes up with the right solution.